Welcome back to Mathics. I have some amazing news to share with you, but before I do, in this video I'll do AMCA 2022, all the problems from 1 to 25. And what is my great news? I'm going to give free lessons to the first 10 people, 10 students who contact me. Okay, each student will get one free lesson, which lasts for 1 hour. And after this one-on-one lesson, I'm going to give you a customized plan, right? So this is going to be like your weakness. This is like your strength. And these are the things that you need to practice to get the best score that you can on this AMCA. So what you need to do, the description box, like below here in the video or on my video channel, I have different ways that you could contact me. So be one of the first 10 people and enjoy your free lesson. Okay, problem one, there is a good way and a bad way of doing it. So the bad way would be just to count the number of these triangles, okay, because it would take longer and it's still a chance of making a mistake. So let's read the question and tell you what is the good way. The math team designed a logo shaped like a multiplication symbol shown below on a grid of 1 inch square. Okay, what is the area of the logo in square inches? Okay, the good way is to connect these lines like this so that you're gonna have 5 squares. So we count the area of squares instead of the area of triangles. And the area of this, okay, we have 4 of this, will be 2. This is a 2. This is a 2. This is a 2. This is a 2. And this is a 2. So 5 times 2 is going to be 10. Okay, problem 2. Well, these shapes like the diamond and the star could be confusing us. So let's read it and see how we could stop that. Consider these two operations. Okay, A, diamond B means square the first number, square the second number, and minus them. Okay, so now that means if A is 5, if it's 3, instead of 5, you put 5 here, you put 3 here. So 5 diamond 3 will be 25, 5 times 5, minus 3 times 3, which will be 16. Okay, so this one is 16, okay? And we no longer need the diamond one. We need the other operation. So let's see here. A star B is what? You take the first number, you write it here. You take the second number, you write it here, and then you subtract. Okay, so in our case, the first number A will be 16. So you put 16 here, okay? And so 16 star 6 would be 16 minus 6, okay? And then you square. Remember, you first have to minus. 16 minus 6 is 10. 10 squared is equal to 100. So the right choice will be, of course, D. Even though this is only problem 3, this one is a little tricky and it's quite possible that you make a mistake. When 3 positive integers a, b, and c are multipled together, their product is 100. Suppose a is smaller than b is smaller than c. In how many ways can the numbers be chosen? Okay, when it says like this, that means a and b cannot be equal. So for example, you can't write 4, 5, 5. Okay, this doesn't work. So I'm pretty sure a lot of you would go on, and I think this is the right thing. You just do a prime factorization of this. So you write 2 squared multiplied by 5 squared. Okay, this is actually 100. 4 times 25. And you would go like, what can I make with this? If you work with it enough, then you say, okay, 2, 5, 10. Okay, so you just write 1. There's a great chance that you move on. But we also have to remember that 1 is also divisor of 100. So what we're going to do is this like this, okay? So we could write it as 1 to 50 will also make 100. So 1, 4, 25 will also make another one. So 1, 5, and 20 will make another one. Okay, we just have to be really careful about this. So the right answer will be E. Okay, if you find problem 4 difficult, we need to practice reflection a little. Then we go back to this question, okay? So I'm gonna just hide this for now, okay? So if I give you like a line, okay, and a point, and I ask you to reflect this point, okay, with this line, okay? So I see a lot of students would go and put it here, okay? They are reflecting it against this point. That's not right. When you want to reflect a point, so you would go perpendicular, okay, to the reflection line, and you would continue the same amount. Okay, so when I ask you to reflect, that's going to be this point. Okay, let's practice a little more. So if I give you this one over here, what would it be? It would be the same amount and in it. Okay, so it would be right over here. So what if I give you a line instead? Okay, I want you to, okay, reflect this red line around this. Okay, so again, you would go with 2 points. You don't care about the line. You would just go, okay, this point becomes this point. And this one, look, it's away, okay? It's further. So this one will have to be further too. So then it would become something like this. This point becomes this point. So, and then you would go and connect these two. So when they're asking you to reflect a complex shape, you would just choose some points within that shape and then reflects the points. And then you connect the points, you get what you're looking for. So let's go and practice this here. Okay. Now for this one, okay, let me get just the options here. I'm not going to show you the options. So you just have to select some points over here. So this one, okay, it's going to be a little small, unfortunately. Okay, this one, you reflect this point. Okay, it will be, you will go perpendicular 90 degrees to the line and you continue, it becomes this, right? And if I go with the blue one, okay, you would see that this one will go the same amount and you have to go like this. So it becomes something like this actually. Okay, and then from here you have to draw your M. Look, you would go from the red to blue, right? And then it would be one side of your M. It would be this one right here. And then you would start to connect them. Okay, so this is, I forgot to read the question. Let's read it. The letter M in the figure below is first reflected over the line Q, which is going to be this one. And we did it already. And then reflected over the line P. Okay, so now we just gotta reflect what we have around this line. Okay, so you see how close it is, the shape? So all we really have to do is choose some points here. So this point becomes this. This point becomes this. Okay, so, and now if you need more, this point becomes this, okay? And then this one is gonna be further apart. So this will also be further apart. This one will also be further apart. So all we have to do is join these. So let's look how it is, okay? So this will be the option E in the question. But remember, when you want to reflect big shapes, you really are reflecting some points. Choose points, reflect the points. So much easier. Okay, problem 5. I think for this type of question, like a small diagram will be a lot better than just writing equations, okay? Anna and Bella are celebrating their birthdays together. 5 years ago, okay, 5 years ago. Okay, when Bella turned 6 years old, so Bella B was 6. She received a newborn kitten. So kitten was newborn, right? So the age of the kitten would be 0. Today, the sum of the ages of the 2 children and the kitten, this is going to be like now, is 30. Okay. So Bella, 5 years later, will be 11. Okay. Kitten, 5 years later, will be 5, of course. So there is another sister, Anna. So the question says, together, okay, Anna, Bella, kitten are 30 years old. So B plus K is 16 plus A is actually 30. Okay, so what is the age of Anna? Of course, 14. Does the question need the age of Anna? No. What does it need? The difference of their ages. This is 14, 3 years older. So C would be the right answer. Okay, problem 6. 3 positive integers are equally spaced on a number line. Okay, because it says equally, so the next number will be 15 plus this distance, whatever it is. Okay, I'm going to call it A. So the one before it is going to be minus by the same distance. So it's going to be 15 minus A. Okay, these are our 3 numbers. The middle number is 15, and the largest number is 4 times the smallest number. Okay, so this one divided by this one, okay, will be 4 times more. Okay, so I'm going to write it like this. So we're going to write this number, the big one, over the small one is going to be 4 times. So from here, maybe just try different numbers, okay, until you find it, okay? Or you could solve the equation, up to you. So for example, you could go, if A is 5, that's 20. 15 minus 5 is 10. The ratio will be 2. You could just find the value of A like this, okay? Or cross multiply. So 15 plus A times 1 is itself. And 4 times of this, 4 times of 15 minus A. Okay, so the left side, I'm just going to change this side. It will be 60 minus 4A is equal to this side, 15 plus A. Okay, so both sides add 4A to them. So it will be, okay, 5A is equal to 60 minus 15. Okay, it's going to be 45. Yes, and A will be 9. Okay, good. So we could also apply it here. You'll see that it works. Okay. So now what does the question want? What is the smallest number? Remember, the smallest number was 15 minus A. A turns out to be 9. So 15 minus 9 is 6. So C is the right answer. Okay, problem 7. When the World Wide Web, the internet, first became popular in the 1990s, download speeds reached a maximum of about 56 kilobytes per second. Okay. Approximately how many minutes would the download of a song, a normal song, have taken at that speed? Okay, so right now in today's speed, it's going to take like a few seconds. But back then, the internet was very, very slow. Okay. Note that there are 8,000 kilobits in a megabyte. Okay. Now, okay, we're gonna download this song that is 4.2 megabytes. Okay. And we know the faster the speed becomes, the shorter the time. Okay. So the question is asking for time, then we have to get this number and divide it by this number to find time. Let's do that. So I'm going to write 4.2, okay, megabyte, okay. So divided by, the speed is going to be 56 kilobyte, okay. But here it says 1 megabyte is 8,000. So to make this into kilobytes, I just have to multiply this by 8,000. Okay, when we do this, okay, the time that we get is going to be this, right? Because the unit they gave us was per second. So when I do this, the answer will be in second, okay? So all I have to do when you have the second and you want to have it minutes, you divide it by 60. So I add 60 here. That's like dividing it by 60. So let's just go and simplify. So I will cancel these two zeros first. Okay, so I'll be like a 6 and 800s. Okay, and look at this, right? This has like the decimal is 1 digit. Okay, and here with 1 zeros, I could cancel them. Let's do that. So it becomes like 42 times 80. Okay. So now let's divide this by 6 is becoming 1. 42 divided by 6 is 7. Okay. Now, if we just multiply these two numbers, 7 times 80 is 560 divided by 56. You'll see that we'll just get 10. Okay, and it's going to be minutes. And the question is asked for us in minutes. So the answer is B. Okay, if you couldn't get this question right, probably you've forgotten the product rule. Okay, let's check that. So first of all, when we have dots over here, that means they're being multiplied. Okay, so all these numbers are being multiplied. That's the first thing. The second thing is, if I ask you to multiply these two numbers, right? How do you do it? So probably you would go multiply 8 times 3 first. Then you multiply 3 times 4. So it's going to be 12. I'm going to write 12. So it will be 24 over 12. Okay, and then you're going to write, okay, it's going to be 2, or you're going to go 2 over 1. You even forget that it's actually 2. Okay, so do we have to simplify them at this stage by 12? Isn't that too late to simplify, right, at this stage? Well, to get this 2, we could simplify at the beginning, right? Because all the numerators, the top numbers are together and bottom numbers are together, you could start simplifying early. So this 3 is canceled with this 3. This becomes 1, this becomes 2. Okay, so the top numbers are 1 times 2. Denominator is 1 times 1, so it's going to be again 2. Okay, so it's going to ask you if you actually know this rule or not. Okay, so, and they didn't give you the next one. The next one will be, so remember, the difference between these two numbers is always 2, 2, 2. So the next number will be times 4 times 6. And we'll continue. Now look, I told you the top numbers and the bottom numbers could cancel. So look what happens. This 3 is canceled with this 3. This 4 will be canceled by this 4. This 5 will be canceled by this 5. And it will continue. Okay. So, and we're going to go, okay, all the way like this. Okay. So what will be left? Okay. So the two numbers will be left from here. And the last two numbers will be left. This 19 and this 20 will be canceled. Okay, so it will be equal to 1 times 2 over 21 times 22. Okay, so you're going to cancel. It's going to be 1. This is going to be 11. So to check this, you just have to multiply this. It's going to be 210 plus 21. Okay, it's going to be 231. So the right answer, okay, is B. Okay, let's see problem 9. A cup of boiling water at 212 is placed to cool in a room whose temperature remains constant at 68 Fahrenheit. Suppose that the difference between the water temperature and the room temperature is halved. divided by 2 every 5 minutes. What is the water temperature in degrees Fahrenheit after 15 minutes? Okay, so after 5 minutes, okay, it's going to divide by 2. So let's see. If here to here is D, I'm going to call it D because of distance. So after 5 minutes, it's going to be here, right? It's going to be between the 2 points. Okay. But after 10 minutes, this D is going to be divided by 2 and then divided by 2. Okay. So this would be half. Okay. The temperature would be at this point. Okay. And now, even after another additional 5 minutes, okay, so we divide this 3 times by 2, and then 3 times by 2, and then like this. So it's the same as dividing this distance by 8, okay? So we just have to find this distance, okay, and then divide it by 8. Let's do that. So D will be 212 minus 68 will be 144. Okay. So we want this one to be divided by 8. 144 divided by 8 is actually 18. Okay. So it would be like here, here, here. So what we find here, the temperature is going to be here. And from here to here is 18. So this temperature we wanted, so the answer will be 68 plus 18. Okay, so it will be, the answer will be 86 right over here. Well, problem 10 is all about the speed and the slope of a line. And if you can't get this question right, that means you don't understand these fully. Let's practice this one together. One sunny day, Ling decided to take a hike in the mountains. She left at her house at 8 o'clock, drove at constant speed of 45 miles per hour, and arrived at the hiking trail at 10. Okay, so we start at 8, we arrive at 10. Okay, and we go at a constant speed. Remember, speed is the slope of the line. When it says constant speed, that means the slope is not changing. As you see in all of these cases, slope is not changing. If the speed was a little like 30, then 45, then 60, right? Then it would become something like this. First a little, then like this, then like this. The slope would change, okay? And here it says 45 miles per hour. In 1 hour, 45. In 2 hours, 90. So that's why we go from 0, okay, to 90 over here, okay? So, but this one, for example, is 45. It's for 1 hour. So definitely this one is wrong, okay? So after hiking for 3 hours, so that means she arrived at her destination. She's spending some time walking. So she's not moving a lot. It is as if she's just stationary and not moving at all for 3 hours. She was 90 kilometers away from home. And still, she's 90 kilometers away from home. Then she decides to go back. If she goes back with the speed of 45, then everything will be symmetrical like this. But the question says she's coming back faster, okay, 60. So we expect the time to be less than 2 hours. So for example, this one, even going back at home, is from 1 to 3, 2 hours. But now it's going to be less, right? So we have 90, okay, kilometers. Okay, if we divide this by 60, so it will be 1.5. So going back will take 1.4 hours. If it's still like a little unclear for you, think about this. When a speed is 60, in 1 hour, we go 60 miles. In half an hour, we go 3. 60 plus 30 is 90, okay? So which one is like that? To go, okay, 2 hours, the way going back has to be 1.5 hours, and it's going to be E, is going to be the right answer. Let's check why. We know we have to get to 90. We go from 8 to 10, 2 hours. We stay here for 3 hours, and in 1.5 hours, we go back home. So, of course, E is the right answer. Problem 11 is all about understanding the question. If you understand the question, guaranteed you will get the right answer. Okay, so let's just see it. Henry the donkey has a very long piece of pasta. He takes a number of bites of pasta each time, eating 3 inches of pasta from the middle of one piece. Okay, so imagine this is very long and I'm going to eat 3 inches. Bang, bang. So now we have 2 pieces and 3 inches are gone. Okay, so and then in the end, he has 10 pieces of pasta whose total length is 17 inches. Okay, and then I will have to eat the one in the middle, maybe eat this one in the middle. Okay, you would see that each time, now I have 4 pieces. If I go and eat in the middle of this one, how many pieces do I have? 1 more. Okay, so I started with 1. How many bites do we need to get there? We need 9 bites. Okay, so that's all the question was about. If you have 9 bites, it's over. So we have 9 bites, each time eating 3, and we have 17 also left at the end. So the answer would be 44 inches, just like that. So once we do this problem, I'm going to change the question a little and make another variation of it. So make sure that you watch that variation as well. Okay, the arrows on the 2 spinners shown below are spun. So in case you don't know what a spinner is, like there is an arrow here, you would just go here and then it stays on one of them. Okay, and it's quite random. So the chance that you get 5 is absolutely the same as getting a 7. Okay. So now I'm asking you, what is the chance I get 8 and not the other 3? I'm pretty sure you would say 1/4. Okay, that's good. So here, the question is asking us, let me read it. The arrows on the 2 spinners shown below are spun. Let the number n equal 10 times the number on the spinner A added to the number on the spinner B. What is the probability that n is a perfect square number? In case you just forgot, perfect square numbers are like this: 4, 9, 16, 25, 36. Why? Because the first time is 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. Okay, so now you have to ask yourself, what is the smallest number that you can make? The smallest number of these would be 5. And from the next spinner, you get 1. So 51. Then you need to ask yourself, what is the largest number I can get? For the first number, you get 8. You multiply it by 10, it would be 80. And the largest number would be 84. So what are the perfect numbers between these 2 numbers? We know 7 squared is 49. 8 squared is 64, which is possible. And after that, we have 9 squared, which is 81. So these are the only 2 numbers within this range. Is that possible to make these? Yes, we have 6 here. We have 4 here. We have 8 here. We have 1 here. So what is the chance of that? Okay. So what is the chance that we get 6? 1/4. What is the chance that after getting 6, we get lucky? Okay, and again, we get a 4, but not the other 3. So that's very, very unlikely. First, like 1/4, and then another 1/4. That makes it quite unlikely. So it will be 1/16. That would be around, well, 6%. Very low, okay? But there is also another chance of getting perfect square number, right? The other one will be the same thing. What is the chance of getting an 8? Not the other 3, 1 over 4. What's the chance of getting 1 and not the other 3? Okay, again, 1 over 4. So both of them happening at the same time. Another 1 over 16. Okay. But here he says, what is the probability that n is a perfect square number? Okay, maybe this one, maybe this one. Okay, so we have more chance of having this. That means we have to add them. Okay, so we're going to go with 1 over 16 plus 1 over 16 is going to be 2 over 16. We simplify it, it's going to be 1 over 8, and that's it. Okay, this would be the right answer. But as I promised, well, they made the question like, oh, they could have made the question a little more challenging by having one of these like the same. So for example, so I'm going to clean this one, this 2. And instead of 2, we're going to have an additional 1 here. Okay, so this is a little slightly more challenging than the actual question. So why don't you solve this and write it in the comment section, okay? Well, it's quite possible that you read this question, you understand it, but not quite fully, and then you get the question wrong. Because when you read this sentence, one positive integer is like 8 more than twice the another number. Are you looking for one number, right? Is that the question? No, let's just read it. So how many positive integers can fill the blank in the sentence below? So there are more. So for example, this could be 1 could be one right answer. 3 could be another one. I don't know, 10 could be another one. You find all of them and then you count how many will that be. That's what the question is. Okay, so let's go with this. First of all, we know they're going to be 2 numbers. Okay, so we're going to have the sum of the 2 numbers. I'm going to call the one A and B are going to be 28. And we know both of them are positive integers. So we know both of them are, okay, positive. So how do you do this? I think the best way for this one is going by like trial and error, right? Just try out different numbers. What is the smallest, okay, positive number that you could use? Well, A would be 1. Okay, now if A is 1, okay, the other number will be 27, okay? So then what would you put here? Like it would be, if A is 1, twice 1 is 2. So B would be 25 more, okay, than twice of A1. Okay, that's like the first number. So it's just like one number. Okay, we don't care if this is 25. Okay, now the next one. If A is 2, okay, then B will be 26. So what number would you write here? Okay, the bigger one is how many more than twice of 2 times of this. Okay, so it's going to be like 26 minus 2 times of this number, which happens to be 22. Okay, so from 25 this time 22. Let's go another one. So A is equal to 3. B will be 25. So 25 minus 2 times of this will be 19. You see that now? The first number we tried was 25, then it was 22, then this is getting 19, okay? We just have to go where it stops, okay? So we could just try a different number here. So if A is, for example, 8, okay, then B will be, okay, 20. So what is the difference? So how many more is this one than twice of this one? It will be 4. So there will be only one more. So A equals 9 will be the last one. You could just try it. If A is 9, Okay, B will be 19. Okay, so it would be 19 minus 2 times of 9 will be only 1. So if this is the last one, if you try A equals 10, looks what happens here. If we go with A equals 10, then B will be 18, and 18 minus 2 times of this will be negative 2, right? That is not going to work, okay? So that is going to be it. We're going to go from A1 to A9. So how many right answers there are? It's going to be this. So before we finish this question, okay, I'm going to change this one. I want you to do it and write in the comment section. So instead of twice, we're just going to make this triple. Okay. And instead of 28, any number would work. Maybe the answer would not be one of the options here because I'm going to go with 34. Okay. So do this, write in the comment section. Problem 14. If you read this question and then you have this dialogue in your head that, wow, like this question is really difficult and I didn't learn this in school. There must be some techniques I don't know. There must be some formulas I don't know. Well, that's not the case, okay? So you just have to stay long enough with a question, and most of the time, after trying hard enough, you can actually solve the question. So in how many ways can the letters in beekeeper be arranged so that the two or more E's do not appear together? Okay, it's so easy to give up, but I want you to do this, and I hope you did this. You just count these 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we think, okay, they're going to be 9 spots. So you would just draw 9 spots for yourself like this: 4, 5, 6, 7, 8, 9. That's it. And then it says the E's should not be together. So can I put 2 E's here? Of course not. Okay, so let's just start. The first one is E. Then this one has to be E. The next one can't be E. This one can't be E. And there you go. Can I put E's in any other form? Nope, because then they will be together. So if I swap these E's together, is that something new? No, all of them are the same. So all 5 E's are forced, and they have to be like this. Okay, no other choice. These are forced. So you just have to go with the other 4. So what letters are left? B, K, P, and R. Luckily, the 4 are all different. Okay, so you just have to ask yourself, maybe you make a list. Okay, maybe you would just say, okay, so for the first spot, how many choices do I have? How many choices do I have? You have 4 letters for this one, 4. Then if I use, for example, B here, can I place B here again? No, because I have only one B. So whatever the first letter is, you can't use it here. So you'll have like 3 choices here. Okay, so 4 multiplied by 10, 3, 2, and 1. So that would be 24. Now, before you go, I want to just give you a little homework. So I'm going to change the question just slightly, but it would change the way you're going to do the question a little. So instead of beekeeper, I'm going to make the question, turn it into beekeeper. So we're going to do it like this, and you're going to have beeb. Okay, so do this one and tell me what your answer is, okay? Okay, this is a shopping question. Imagine you go shopping and you're torn between these 2 options. One option is 1 liter of it, $20. The other one is 2 liters, $30. Which one is more economic? Which one is cheaper? Okay, Of course, this one will be $30, but you get 2 liters for it. So for 1 liter, this one will be only $15. So you would save, okay, if you buy this one, okay. So, and this is exactly the same kind of question, okay? But they just showed you all the items on a graph so that you could compare this easily. So let's go and read it. Laszlo went online to shop for black pepper and found 30 different black pepper options varying in weight and price shown in the scatter plot below. In ounces, what is the weight of the pepper that offers the lowest price per ounce? Okay. So let's just compare all of these together. So all of these are only 1 ounce, okay, like 1 liter in my example. Okay, for the same amount, this one is almost $3. 1 ounce, $3. What is the cheapest of these 4? Just the lowest one, right? So that means in all of this, I could make another one among these options. The cheapest one is always the one that is down, okay? These items that go up, okay, will get more expensive. So for example, for this one, you have to pay almost $5 for 2 ounces. 1 ounce would be 2.5, okay? So that means you have to come to the conclusion, okay? So you just have to ignore all of these, only care for the ones that are just down over here. So I'm just gonna ignore all of these, okay? So we only have from each column, 1 item. So this one, okay, is a little over $1. So this one is like 1.1, for example. Okay. So this one, okay, let's just see this item over here. It's gonna be $2 for 1.5. Okay, but this one is actually cheaper because it's gonna be $2, okay, for 2 ounces. So $1, 1 ounce. Okay, so this is not good. This is not good. This is really good. So far, this is the winner. This one, the price will be for 2.5 ounces. This is a little more than 2.5, right? It's gonna be like 2.7. So this one is actually more than 1. So this one is also out then. But the next item is actually very cheap. Look at it. It's going to be less than 1, right? So 2.5 divided by 3. So when you buy this one for 1 ounce, it's just gotta be like 0.8 something. Okay, so this one is really good. Okay, when you try these numbers, so far, this is the one that is good. This will be, again, with the same reasoning, more than $1 for 1 ounce. This one, as you see, is almost 1 per 1 ounce, $1. So that one is not good. So the final decision has to come between these two, okay? So this one was 2.5 almost for 3 ounces, okay? The other one, look at this one. It will be $4.5, okay, for 5, okay? So now you have to decide which one is actually, okay, cheaper, okay? So this one, if you turn it into decimals, you could just multiply both of them by 2. Then it would become 9/10. So it's going to be 0.9, this one. But this one is actually cheaper. This is like 0.8 something, okay? So to just like get a feeling of it, So if you're not sure, if it's 2.4 instead of 2.5 when you divide it, it's going to be 0.8. Okay, just a little more than that. Okay, if you're not sure that this one, when you turn it into decimal, it's going to be almost 0.8, definitely less than 0.9. So we know that this is the right answer. Okay, but if this is not the way you feel comfortable with, think about these two that we have at the beginning. We have 4.5 and 5. Okay, so we multiply both of these by 6. And I multiply both of these by 10. This way, okay, the denominator, both of them will be 30. Let's go with this one, 45 over 5. So 24 and 30. This one, the expensive one, this one will be 28 over 30. When I multiply them, this one will be 25 over 30. So you would see that this one is definitely the cheaper one. Okay, so 3 would be the right answer. Okay, so before we move on to the next question, let me leave you some homework. Let's do the question the other way around. So I want you to pick the most expensive one. Okay, which one is the highest, okay, price per ounce? Okay, so you have to go the other way around. Let me which one is the highest in the comment section below. Problem 16. When you see a problem like this, if you're somebody who is just writing, okay, there are 4 numbers, I'm going to put A, B, C, D. Well, usually this is not the best idea. Instead, you should just start by trying out different numbers. Okay, so the first one will be just coming up with numbers that follow the same instructions here. Okay, so let me read the question first. 4 numbers are written in a row. The average of the first 2 is 21. Okay, you could write any numbers that follow this. So any number that you just multiply by this by 2, okay, you could write 1032. Because when you add these two numbers, it's going to be 42. When you divide them by 2, it's going to be 21. So I want to write something extreme to show you something. I'm going to write 1 and 41. Okay, like any number. So I'm going to write this one. And the average of the middle 2 number is 26. So 26 times 2 is 52. So 52 minus this. Now, if I add these two, 41 and 11, 52 divided by 2, 26. And the average of the last 2 numbers is 30. Okay. Good. So it's going to be 16 minus 11. I'm going to go 49. Right? So what is the average of the first and the last number? 49 plus 1 divided by 2. How easy is that, right? It's going to be 25. So if you can't do this question, it's because you're overthinking it, right? Because any numbers that follows this instruction will work. Why do we have to write and work with ABC, like write equation and things like that, okay? In order to understand this problem better, let's just focus on this problem instead first, okay? Now, what is the unit digit of this? 1 times 23 times 17 times 2 times 35 times blah, blah, blah. It could just go on forever with other numbers. It doesn't matter. Okay, look. So we know that when you multiply 2 times 5, you get 10, and 10 will just create a 0. Okay, so we're just going to just apply the same rule here. There is a 2 here, and 75 has a 5 in it. It's 7 times 5. So that means there is going to be a 2 times 5, and the rest doesn't matter. Infinite number of 9s, infinite number of whatever you just imagine. Because there is a 2 and there is a 5, okay, the units digit will be 0. The number on the farmost right side has a 0 in it. Okay, so this is the same concept in this question, okay? We're just gonna go with this. Let me read it. If n is an even positive integer, the double factorial notation represents the product of all the even integers from 2 to n. For example, this. What is the units digit of the following sum? Okay. In case you're not a native speaker, okay, so the units digit will be this one, okay? This is what we mean. Okay, so remember, we just have to continue. This will be 2 plus, this one will be 2 times 4. Okay, the last one will be 2 times 4 times 6. Okay, we just have to continue it a little bit more. 2 times, the next one, 2 times 4 times 6 times 8. And that's it. The next one will have a 2 and a 5 in it. Okay, because I'm going to write the 10. The rest of them will have, okay, the unit digit of 0. So when you have all these numbers that start with 10, okay, and then like 10, another number, 9, 9, 9, 9, 7. It doesn't matter. We just look at these numbers. Now, when you add all of these numbers, the zeros will make no difference. There will be only this 3 that will be going down here. Sorry. Oh, okay. Sorry, guys. Oh my God, that was really strong. That was painful too. Okay. So where was I? Okay, so the last numbers will produce just 0, 0, 0. So we just need to go with this, okay? Okay, now let's add all the units digit. So the first one is a 2, okay, plus this one will create 8. So far it's 0, okay? So plus this one, 8 times 6, 48, okay? Plus another 8, okay? This one is 8 times 6, 48. You just take this 8 here. 8 multiplied by 8 is 64. You just take this 4. Okay. So even, look, this 2 and 8, they create a 10, right? Which is a 0. You could even like throw them away. So what you have is 8 plus 4. What is left is 1. 1 goes to the right next side. So this is what will be left. So we're going to choose the option B right over here. For this problem, we need to be smart and not spend a lot of time doing it, okay? And it's quite possible. Let me read the question first. Okay, the midpoints of the 4 sides of a rectangle are this, okay? What is the area of the rectangle? Let me just show this point. This is -3 and 0. Okay, the other point is going to be 5. Okay, 2 and 0. X will be 2 and 0. This will be another one. Okay, 5 and 4. 5 and 4 will be somewhere like this. Okay, and 0 and 4. It will be right over here. Okay, so if I connect all of these together, what shape is this? Okay, you would see that all the sides are parallel. So this is a parallelogram. And this is the midpoint of a rectangle. So this is the confusing part. Like, do we really need to draw the rectangle? See, we don't really need to do that, okay? So this would be, if we have this given rectangle and we connect the inside parts, okay, it will be something like this, right? It would be a diamond shape, a parallelogram like this, okay? So we know the area of the rectangle is 2 times of the area of the parallelogram. If you're not sure, you could just divide it. Like if you add all of these, there will be 8 of the similar triangles. 4 of them is for this parallelogram. So this is half. Okay. So in case you wonder what the rectangle looks, I'm just gonna draw it, but we're not gonna use it, okay? So because it's gonna be the same shape, this will be the rectangle. I'm gonna go, let me just make this larger. Okay, we're gonna go something like this. Okay, and then we're gonna go like this, and like this, okay? Are we gonna use this rectangle and find all the points and minus them? No, such a bad idea, okay? We just wanna find the area of this parallelogram, the yellow one, times it by 2. So let me clean this one as well. So in case you've forgotten the area of parallelogram, it's not hard. Just imagine we take this one, this area, and we just put it back over here. Okay, so the shape really, to find that area, you just have to find this area instead. And it's gonna be a rectangle with this 1, 2, 3, 4. This will be 5. So the area of this 4 times 5 is 20. But remember, the area of the rectangle was 2 times of this. Okay, so the answer will be 20 times 2, 40, which is gonna be this one. Okay, let's do problem 19. Mr. Ramis gave a test to his class of 20 students. The dot plot below shows the distribution of test scores. Well, I've written test scores this way so that we understand the task better. So later, Mr. Ramis discovered that there was a scoring error on one of the questions. He regraded the test, awarding some of the students 5 extra points, which increased the median test score to 85. Okay, what is the minimum number of students who received extra points? Okay, and the rest. So right now, how do we find the median, right? The median is the middle number, okay? But how do we find the middle number? Okay, so look. So for example, this 5 goes with this 5, right? Imagine you just putting them aside, and then another 3 over here, and then another 3 for here, and this one and this one, okay? So there you go. These are your 2 middle numbers, okay? So here will be 9 numbers from here. So from here will be another 9 numbers. So just for your information, the 10th number and the 11th number, okay? The average of these two will give the median, 80 plus 80 divided by 2. So I have a question for you. Because it says the median, the smallest number, the minimum. So if I make this 80, if I add 5 to this student, he will go sit here. Does it change the median, these two here in the middle? No, not really, okay? If I change this 90 to 95, not here. So if we want to change the median, it has to go, okay, before the median, okay, from the left to the right side, okay, from the left of the median to the right of the median, okay? So let's see how many of them we need, okay? So these are the two worded in the middle, okay? Because here it says the minimum, okay? So imagine we take one of these numbers, okay, I'm gonna go, all of these IDs are equal. So if I add 5 to this, what happens, right? Remember, even if I add 5 to this one, it will go sit here after that 80, okay? So if I add 5 to one of these 85s, this one is the same as this one being 85, right? So we'll have 3 85s and 3 80s, okay? But still, we would see that the median, these two 80s didn't change. Now, if I take another of these 80s and add 5 to them, okay? Remember, even if I make this one 85, okay, this one will take the place of this one. so it wouldn't change. Good. So now, then this one be 85. If I just change 2, now the average will be 82.5. We don't want this. We want the average to be 85. So if I add another 5 here, there you go. We're going to have 2 85s, and that will be it. So we need to change 3 people at least. Those people should be from 80s, okay, to 85s, okay? So we're going to go, we just need these 3 of these people to be changed this way, okay? So the right answer will be B. Well, for problem 20, the technique you use and the approach you go will determine how difficult this question is. If you just go on and write some variables here, it's going to make it really, really difficult. Okay, but you don't have to. Let me read the question. The grid below is to be filled with integers in such a way that the sum of the numbers in each row and the sum of the numbers in each column are the same. 4 numbers are missing. The number x in the lower left corner is larger than the other 3 numbers. Very important. What is the smallest possible value of x? Okay, so they have already given this up. So if you add these two, okay, 9 plus 5, okay, is 14, plus minus negative 2 is going to be 12. Okay, you check with the other one, it's also 12. So what should we do here? Write the equations? No, just because here it says from the smallest possible value, this is the smallest possible value. So instead of this, we're going to have negative 1, negative 2, negative 3. The sum of them are going to be positive 12. So this is 15. Okay. Is negative 1 larger than 15? No. So this option is out. Okay. Let's just try another one. So now let's go with this being 5. If this is 5, so 5 plus a negative 2 is 3. So this will be 9. Is 5 larger than 9? No. Okay, so this one is also out. Very easy, isn't it? Now, if x is 6, this would be negative 2 will be 4. This will be 8, but still not larger. So this is also out. So 2 more to go. If this is 8, there will be 6. This will also be 6. Now, in this case, 8 is actually larger than that. So in this case, this will also, you could also check, this will be 16 minus 4. So you could also check the other one. So this is 5. This will be also 7. Okay, yeah, great. So in this case, you will see that 8 is larger than all the 3. So there you go. You have your right answer. And it's problem 20. Easy for problem 20. Problem 21. Well, in my opinion, this is very, very easy to be problem 21. And if you can't do this, check to see if you're reading the instruction and the question too fast and too quickly, okay? Because I think if you read it slowly, if you understand every bit, most likely you will get the question right. So let's go and do it. Steph scored 15 baskets out of 20 attempts in the first half of a game and 10 baskets out of the 10 attempts in the second half, okay? So here, we could just simplify. This is like 3 over 4, okay? This is like 1. This is 100%. This is 75%. C, Candice, took 12 attempts in the first half and 18 attempts in the second. In each half, Steph scored a higher percentage of basket than Candice, right? So this is like, I've seen it in my students, they don't notice this, right? This sentence, they're reading it too quickly. Surprisingly, they ended up with the same overall percentage of basket scores. How? So there are 2 halves. One person plays better than the other person in each half. And at the end, both of them are equal. I'm going to explain that. Okay. So how many more baskets did Candice score in the second half than the first? Okay, let's go. This is also another important sentence. Let's see. Now we know the overall percentage are the same. Okay, so the overall percentage, this person had 20 shots, 10 shots, a total of 30 shots. He scored a 15 and a 10. That's his overall, 5/6. What should be overall of candies? The same thing, right? Because it says the overall score is going to be 30. So this is 25, okay? So for example, if this one, you just have to from here, try out different numbers, try and error. So I'm asking you, is it possible for this person to score 19 out of 18? A joke, right? Impossible. Is it possible for the second half that the candies from 18 shots, the score is 18 shots? It's possible, but here the question says that Steph has scored a higher percentage of baskets than candies, okay, in each half. Okay, so this 18 is not allowed. Okay, so what is the next number to try? 17. If this is 17, we know the overall is 25. So if the overall 25 minus 17 is 8. Okay, and that's all about it. So this one is actually, if you simplify this one, you divide both of them by 2. This is 2/3. Okay, so it will also be around 66%. This is 75%. And this one definitely works. Okay, now we tried 17, right? Could there be more than one right answers, right? So because we check 18 was impossible. If this one is instead of 17, 16, right? We know it's going to be 25. So this person will have to score, Candice score 9 here. But 9/12, dividing both of them by 3 is going to be 3/4, which would be equal to this. But we know a step has to be higher than this, so not allowed. Okay, so as simple as that. So that means, okay, the person, like Candice scored, has to score 17 in the second one and 8 in the first one. If it's not like this, then the percentages of a step would not be larger than Candice in every half. Okay, so what is the question one? It wants like the number 17 minus 8. So a lot of people would go from here and choose B, and all their hard work goes into trash. So 17 minus 8 will be 9. So C is the right answer. But as I said, how can somebody play better in each half but end up being the same? So let me explain that. See, in both of these cases, this person was 17, this person. Both of them are very close. This one is 100%, okay? This one is almost also 100%. So both of the performances is very great in the second half. Both of these people do poorly on the first half compared to themselves, their own performance. This person was like 76%, okay? But why is that? Let me explain. We see now. So both of them are doing really, really well, okay, in the second half. But on this one, this person, Steph, even though performance was good, on a good day, he only attempted this 10, right? But the other percent was not that good, but 18 of his scores and his tries and his attempts were on this part. Whereas here was like only 12. He only had 12 on a bad day. But Steph used up 20 of his shots on a bad day. Okay, that's why things were balanced out. Well, if you can't do problem 22, probably you just have the habit of just writing equations and things like that, writing down variables, and then it gets so messy and mixed up that you can't do it. Well, you shouldn't do that. Let's read the question. A bus takes 2 minutes to drive from one stop to the next and waits 1 minute at each stop to let passengers board. Okay, So board, by the way, means like get into it if you're not a native speaker, like just go inside the vehicle. Zia takes 5 minutes to walk from one bus stop to the next. Okay. As Zia reaches a bus stop, if the bus is at the previous stop or has already left the previous stop, then she will wait for the bus. What does that mean, right? So for example, if Zia is here, okay, and you see, oh, the bus is here in the middle of the way, she will stop at the station. Or if just she sees that the bus is already at the other station, she's at this station, says, why do I go in the middle of the way? She will be risking too much because she could be in the middle and the bus will now wait for her and she will just miss the bus. Okay. So let's just keep reading. Otherwise, she will start walking toward the next stop. Suppose the bus and Zia start at the same time toward the library with the bus 3 stops behind. After how many minutes will Zia board the bus? Okay, just see it like there is a story, right? See it if like you are the person. Okay, so it's okay. So if this is you, not Zia, after 5 minutes, okay, you're gonna be here. Okay. But where's the bus after 5 minutes? You could just draw it here. The bus will get here in 2 minutes plus 2. Wait here plus 1. Okay. So again, 2 more minutes. The bus will be here. But it's going to wait here for another one. So you would see that the distance between them is like 2 stops here. And right now it's a good opinion, like good idea to look at the options. So because all the options are less than 15, let's go what happens after 15 minutes. Zia will go at this station. Okay, 3 5 15 minutes. Plus 5, plus 5. So where is the bus now? The bus is like plus 2, plus 1, plus 2, plus 1. Let me just change color. So there was, so 6 minutes so far. Okay. 8 minutes plus 2 plus another one, 9 minutes. 2 and 1 again. This is going to be 12 minutes. Okay, but look at here. After 14 minutes, okay, the bus is already at this station. Okay, this is 14 minutes. It's going to stay here for another one. But after 14 minutes, where was Zia, or in our case, where are we? So 5 plus 5. Zia is here after 14 minutes. Okay, but the bus is already there. But once it's completed, once Zia looks, it stays here. Okay. Okay, so exactly at 15 minutes, the bus is at the previous, like a bus stop, is about to leave. Okay, so Zia looks at the person. So the bus is coming. So Zia will wait for the bus in this case. Okay, so 15 minutes so far, another 2 minutes here. So after 17 minutes, Zia and the bus are at the station. And she has 1 minute, okay, to board. So this is 17 minutes. And you would see that 18 is gone. Because 17 minutes, both of them are there. Maybe it takes up to a minute for them to board. So that's why 18 is not there, so that nobody will be confused. So after 17 minutes, Zia will be there. Is this a math questions? No, it's just like reading instructions and following instructions, right? It's not really mathematics, is it? Well, for all the previous questions, I just this is easy, this is easy, this is easy, but this one, in my opinion, is actually difficult for AMC 8, okay? It's a little tricky. But that doesn't mean we can't do it or we can't understand it. No, still manageable. Now, a triangle or a circle is placed in each of the 9 squares in a 3 by 3 grid. Okay. Shown below is a sample configuration with 3 triangles in a line. Now let's practice. So this is my question. How many ways can you, fill this larger grid? So how many configurations, how many possibilities are there for filling this up? So each of these is small. You put either a triangle or an O, like a circle. So 2 for here, 2 for here, 2 for here. So we will give like a total of 2 to power of 2 times 2 times 2 to the power of 9. Okay, that's the total number of the ways you can just do. Okay, but let's see what the question wants. How many configurations will have 3 triangles in a line and 3 circles or O's in another line? Okay, so we know that it could either be like this, or it could be like this. Like you put triangles this way. Do we need to count both of them? No. We do them vertically and then we'll multiply it by 2 because the shape is symmetrical, right? Whatever it is when we go up and down, left to right, it will also be the same. Okay, so let's only do it vertically. Okay. Now, before we start, is this one of the answers? Is this one of the configuration the question wants? How many configurations will have 3 triangles in a line and 3 O's? It has the 3 triangles, but is there 3 O? No, this one is not one of them. Okay. So we need at least 1 triangle and another one you pick. Okay, will be 3 O's. How many ways can we do this? To pick 2 of these columns and then put triangles or O's in there. Okay, do you know the answer? So first, we want to choose 2 columns from 3 columns. You could choose 1 and 3, 1 and 2, or 2 and 3. Okay, so there are 3 ways to choose 2 columns. So I could also write it 3. We also know this is the combination of 3 and 2. Either way you feel comfortable. So I'm going to just write 3. Now imagine we choose this one and this one. So I could go make the first one O, 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 or I could go the first one triangles, the other one O, O, O. Okay, so that would make another 2. So let's just choose O, O, O. Maybe I choose this one, triangle, triangle, triangle. Good. So, and these 3 are free, aren't they? Now I could put anything I want. I could put either triangle or O here, triangle or O here, triangle or O here. That would make, as we said, 2 times 2 times 2. Okay. So it will be again another 8 to the power of 3. So multiply all of this. It will be 48. Okay. We did it vertically. We need to do it horizontally as well. So 48 times 2 will be 96. Is this the answer? No. 96 is not the right answer. So, but why? Like my argument was correct all the way, wasn't it? No, it wasn't. Let's see why 96 is not the answer. Okay. Because there is a problem here. Look, we first chose this one, and then we had 8 possibilities here. Of my 8 possibilities, okay, there was also 1 O here, 1 O here, 1 O here, right? Okay, this is one of this 8. There was like 8. This was one of them. Okay, now let's see another story. Okay. Okay, now remember, previous time we selected this one and this one, right? Randomly. Okay. Now it's quite possible that the next time we could have chosen this one and this one, right? So, and one of the possibilities would be this. O, 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 triangle, 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 right? These are the first 2. We selected 2 columns, one of them randomly O, the other one like triangles. And remember, here we also have 8 choices. this one, whatever, this one, whatever, this one, whatever. So it's again possible to go O and O and O. And look, the two shapes are the same. What does that mean? That means this shape, we have counted this 2 times, right? We have done over counting in our analysis, okay? So maybe we could have chosen another method, or now we need to just subtract, okay, the ones that we have over counted. We had 48, and the ones that are like, we have the columns are O and triangle, or triangle, triangle, O. These ones in our method, we have counted them 2 times. So let's go and subtract, or we could do another way. But subtracting it is easier. So let's just see here. Now, how many ways do we have 2 columns of triangles or 2 columns of O's? Let's see here. Now, the ones that we have overcounted are being like this. Maybe we have 1 row of triangles here, okay? And the rest will be like O's, O's, O's like this, okay? That would be like one of them that we have overcounted. Or it could be like the 3 triangles could be here, 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 and the rest all O's, okay? Or 1 row of triangles could be here. This will be O's, O's, O's. Or we could have 1 column of circles and 2 column of triangles. So it would be something like this. Maybe we have O, 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 or triangle, triangle, triangle. Okay? Or no, maybe the O's were here. So as you see, okay, there will be like 6 like this. O's are like this. The rest will be triangles. Or O's are here. The rest will be triangles. So with this, you would see that 6 of them, these 6, we have overcounted. So we need to go and take this 48 and minus it by 6. So it will be 42. But this 42 was for the vertical one. We still need to multiply that by 2. And we're going to get 84, which is going to be this one. Now, is it possible to do problem 24, even if we can't really imagine how this polygon is going to turn into this prism? If we can't imagine it, can we still do it? The answer is yes, okay? So all we have to do is just draw a prism, okay? And then match the lines, okay? So let's do that. The figure below shows a polygon, blah, 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 consisting of rectangles and right triangles. By the way, we know that the squares are also rectangles. When it's a rectangles, it's quite possible that this one turns out to be a square. That's okay. So when cut out and folded on a dotted line, the polygon forms a triangle or prism. Suppose that AHEF is 8 and GH is 14. What is the volume of the prism? Okay. Now, I want you to focus on this right triangle. Which of these is the largest one? Okay, it's going to be the hypotenuse, right? So it would be this one is the largest side. Now look at this one. Which one is the largest of all 3? Huh? I think this. So let's go and match this one as well, and this one as well. Now, the question has given us this, the question said this is 8. In front of it, the dotted one is also 8. Look, this is the other side. Like this is the other triangle. So all of these are actually 8. Okay, so it's going to be this one. And why do we have only 2? The 3 lines here, why do they become 2? Because they're going to be folded together. So we know that this is also 8. So all the red ones are 8 here in the picture. So we also have the third one, the smallest side of the triangle. I'm going to go purple, purple, and purple. So it would be this one. And again, it will be only 2, not 3. Now let's focus on these instead. Look, now this is a rectangle, orange and blue. It would be this rectangle over here, right? This is a rectangle, orange, blue. That's very good. So you would see that, look, these are the same lines. And in this square, if I draw this one, okay, this one will also be this blue over here, right? Just follow the colors, okay? Blue, blue, red, red would be this one. Blue, blue, red, red, okay? That's very good. So these are the blue ones as well. Now let's just follow this one. Okay, and let's focus on this one over here, okay? It's going to be again another rectangle, okay? And these will be actually, this blue is right over here, okay? So let's draw that one as well. Now we know that the question has also said that EF is also 8, which is the blue one. So that means all blue that you see, they're also 8, 8, 8, 8, 8. So here, 8, 8. So the blue one and the red one are both 8. So, and the purple one, because here it said from here to here is 14. So that means the purple one is also 6. Did we have to imagine stuff? No. Well, some people have harder time imagining things, including me, but that doesn't mean we can't do the questions. So this will be 6 and this will be 6. Now how to find the area of the prism, okay? So this would be, we have to find the area of this triangle, okay? So it's going to be 8 times 6 divided by 2. And we need to multiply that number by the height, which is going to be, this case, the blue one, which is going to be multiplied by the height. So this will also be 8. So I'm going to go, this 2 goes with this 3. 8 times 8 is 64. So this is equal to 64 times 3. When you multiply this, it's going to be 192. And there you go. That's the volume. And we did it without having to imagine. This goes there. Okay? So, well, problem 25 is very easy if you just use the right way and the right technique. So let's read it. A cricket randomly hops between 4 leaves, on each turn hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? So when we start, we get like a little confused, like what's going on? Okay. Now, does it make sense to write, for example, the first leaf A, this one B, this one C, and this one D? Do we need to do that? Okay, the answer is no. Okay, see, look, how is this leaf different than this leaf, right? Different than this leaf. Well, all of these, to the eyes of the cricket, all of this are different, right? In what way? This one is the starting point. This is not the starting point. Okay, so the ones that are not the starting point, they all are equal. So why call them B, C, D to just create different possibilities? So I'm going to call this one B, this one B, and this one B. Why? All of them are equal. So the cricket is starting from A. So what is the chance, okay, that A goes to one of the B's, right? What is the chance of that happening? 100%, right? Because the cricket has no chance, okay, it has to go to a B, okay? But after here, once the cricket is here, okay, now there are 2 possibilities. Maybe it can go to B, or maybe it can return back to A. So from B, it's going to become like 2. Okay, it's going to be B. We could go back to A. Okay, or we could go A, B. Okay, and then from B, we could still go to another B. Okay, so we were here. If we're back to A, again, we definitely have to go to one of the B's because we're back to the starting position. Okay. But if we are at B, again, this is going to be two possibilities. So maybe we go to A, or maybe we go to B. So I have to make another one like this. A, B, B. We are still at B. Okay. So how many hops have we had so far? 3 hops. 1, 2, 3. So we need one more hop. In all the possibilities, we want to go back. So all of them will have to turn into A because we want the possibility of this. Okay. Now let's go to the beginning. Let me change the color. We are at A, a starting position. What is the chance we go to B? 100%. 1. But look, once you are at B, what is the chance to go to another B? You have from these 3 options, one of them is A, from these 3 toward B, so 2/3. Okay, once you are again at B, again 2/3. Okay, so but here you are at B this time, you want to go back to A. Look, you again have 3 possibilities here. Go to A, or 2 possibilities for B. This one, we want 1/3. So the probability of this happening is 2/3 times 2/3 times 1/3. So let's just go and just multiply this. This will be 4/27. Okay. Yes, that's very good. Now, how about the other one? Look, we are at A. Okay, we definitely have to go to B. From B to go to A, it was 1/3. From A going to B, it was 100%, just 1, like the first one. And from B going to A is again 1/3. So it will be like this: 1 times, I don't have to write 1, just the ones here. It's a waste of time. I'm just writing this to show you. So the probability of the second one happening is 1/9. Let me write it here. And there will be the next one. So which is going to be, let me change color. A to B, 1. Okay, B to B is 2/3. Okay, and now look, the possibility of going B to A is 1/3, we already have this. But look at the last one. We are already at A. Can we hop and go back to A? No, so the last one will be actually 0. So it's going to be 1 times 2/3 times 1/3 times 0. So this one is, we didn't even have to write it. Okay, so this one is out. So we only are left with these 2 possibilities. We just have to add them. So 4/27 plus 1/9. Instead of 9, I could write 3/27. That's 1/9. When we add them, it's going to be 7/27. So this would be the right answer to the question.